Dear students, let's start lecture number 16 on the topic electromagnetic spectrum of the course wireless network. Let's begin with uh, our today's outline. So first of all, we will revise lecture number 15. Then we will uh, dive into electromagnetic spectrum, and then we will see different kind of waves which are the part of that electromagnetic spectrum. And then we will see, is a radio wave the same as gamma rays? And then I'll give you assignment, and then I'll share resources which I have used in making these slides, and then we have question answer session. So let's start with electromagnetic waves. As you know that in this was our previous lecture. So if you have seen ocean, so you know waves very well then. Electromagnetic waves, or EM, travel through space just like ocean waves. So if you have seen ocean waves, so you have seen waves practically. So waves that are created as a result of vibration between electromagnetic and magnetic field. Waves are composed of oscillating magnetic field and electric field. The energy of carrying radio and TV signals, we call it as electromagnetic waves. The heat from the heat from a microwave oven, the light from the sun, or X-rays and gamma rays used in hospitals are all form of electromagnetic waves. Their form might be different, but they share some common properties. They travel at the speed of light in space. Let's look at several terms of wave first. So, as you know, a wave has a highest point called crest. So, if you consider this as a wave, so this is its topmost point. So, this is called crest, and this is its um, uh, mm, lowest point. So, we call it as trough. So the vertical distance between a crust and the wave central axis is amplitude. So this is called amplitude. Amplitude is about the strength of the wave or power of the wave vibration or isolation oscillation. So if you can say this amplitude, which is also called intensity or power or energy, so this is called amplitude. So other words, greater the amplitude of the wave, more energy it carries. So this is actually shows how much energy this wave this how much energy this waves have. Uh, Other words, the greater the amplitude of the wave, the more energy it carries. In the wireless communication, uh, wireless amplitude means strong signals. We can talk about amplitude, power, energy, intensity are used interchangeably. Now, let's come to another property, that is wavelength. The wavelength is the distance from any point on the wave to the same point on the next. You can see here that we can count it from. You can measure the wavelength from one lower point to the next one. So one lower point to the next lower point. We can call this as a wavelength, or you can measure the wavelength from one lower point to another lower point, or from one trough to another trough. We call it as a wavelength, or 2 points on the axis. So you can see these are the 2 points on the axis. We call this as a wavelength as well. By convention, we mean the wavelength from the top of a crust to the top of the next one. So from this crust to this crust, we could call this as a wavelength as well. The measure of unit of wavelength is meter. Now come to the third property, that is called frequency. If you draw an imaginary line, a vertical line in space, you can consider this as a vertical line in space. The frequency of wave is how often a wave cycle passes the line. So how often the wave cycle. So if you consider this as a cycle, so how many cycles pass through this vertical line, we call it as a frequency, how many cycles are passed through this vertical line in or in a certain period of time, with a certain time period, or within a 1 second, we call this as a frequency. So number of times a wavelength wave cycles repeats within a certain time. Look at this wave. It repeats its cycle 3 times within 1 second. You can see here that this is one cycle, second and third. So these 3 cycles, so this is cycle number 1, this is cycle number 2, and this is cycle number 3. So these 3 cycles are passing through a line within a second. So this we call it as a frequency. And hertz is the unit of frequency. Or 1 hertz means a wave repeats one cycle within a 1 second. So as 3 cycles are passing here, so we call it as a 3 hertz. Uh, so the wave frequency is 3 hertz because it repeats 3 cycles per second. So how many cycles are passes through this vertical line within a second, we call it as a frequency. Now relationship between frequency and wavelength. The wave with longer wavelength has lower frequency, and shorter wavelength means higher frequency. So as they are inversely proportional to each other, so amplitude has nothing to do with frequency. So you have to remember that frequency and wavelength, they are inversely proportional to each other, but amplitude has nothing to do with frequency. Waves of different frequency can have the same amplitude. Waves of the same frequency can have the different amplitude. All waves of different frequency travel at the same speed, the speed of light in an empty space. Now, this is the formula. You can see F is equal to C by lambda. C means speed of light by lambda, and this is equal to 3 multiplied 10 raised to power 10 raised to power millisecond, 10 raised to power 8 millisecond. Now this is lambda, this is wavelength. Frequency and wavelength are inversely related, as you know. If we increase frequency, so wavelength will be decreasing. So if wavelength is increasing, so frequency will be decreasing, as they are inversely proportional to each other. The lower the frequency, the higher the wavelength. The higher the frequency, the shorter the wavelength. So they are inversely proportional to each other. Now, this was the assignment. If you remember, as the wavelength of a wave in a uniform medium increases, its speeds will be. So these were the 3 options. So the correct answer is remain the same. As the wavelength of a wave in a uniform medium increases, its frequency will be decreased. The speed of, now the third one, the speed of a wave depend upon uh, casually affected by the first one is true, the properties of the medium through which the wave travels. So this is correct answer. I hope that you have uh, uh, answered all these uh, questions. Now come to lecture number 16, which was on the topic electromagnetic spectrum. Electromagnetic waves. If you have seen uh, now, come to electromagnetic spectrum. The whole range of frequencies or wavelength of electromagnetic waves arranged in order is known as electromagnetic spectrum. So now, how they are arranged? They are arranged on the basis of their frequencies and wavelengths. I'll show you in a while in my coming on my in my coming slides. I'll show you that on next slides. Arranged in order is known as electromagnetic spectrum. It is a classification of electromagnetic waves according to frequencies or wavelengths. It is a range. It is range of frequencies which electromagnetic waves can propagate. It consists of the following waves. This is the sequence. You can see radio waves, microwaves, infrared waves, or visible light, infraviolet rays, X rays, and gamma rays. This is called R for gamma and gamma rays. So there are different kind of waves available, like radio wave, as you know. So the radio captures radio waves emitted by radio stations, bringing your favorite tunes. Radio waves are also emitted by stars and gases in space. Microwave radiation will cook your popcorns in just a few minutes, but it also used by astronomers to learn about structure of nearby uh, n- uh, structure of nearby glaciers. Infrared night vision googles pick up the infralight emitted by our skin and objects with heat. In space, infrared light help us map the dust between stars. Visible, our eyes detect visible light. Fireflies, light bulbs, and stars all emit uh, visible light. Ultraviolet. So ultraviolet radiation is emitted by sun and are the reason skin tans and burns. Hot object in space emit ultraviolet radiation as well. X-rays are our dentists use X-rays to imagine your teeth, and airport security uses them to see through your bag. Hot gases in the universe also emit uh, X-rays. Gamma rays. Doctors use gamma rays imaging to see inside your body. The biggest gamma rays generator of all it all is the universe. Is the radio wave the same as gamma rays? A radio waves completely different physical object than gamma rays. They are produced in different processes and are detected in different ways, but they are not fundamentally different. Radio waves, gamma rays, visible light, and all other part of the electromagnetic spectrum are electromagnetic radiations. Electromagnetic radiation can be described in terms of a stream of massless particles called photons, each traveling in a wave-like pattern at the speed of light. Each photon contains a certain amount of energy. The different types of radiations are defined by the amount of energy found in the photons. Radio waves have photons with low energies. Microwave photons have a little more energy than. Radio waves, infrared photons have still more than visible ultraviolet X-rays. and the most energetic of all gamma rays. This is the diagram. You can see here that that you have um, radio wave, microwave, infrared, visible, ultraviolet, X-rays, and gamma rays. So here you can see, here on the top of this order, we have on the top we have this wave. You can see here, you can see the that wave shows its behavior. Like on the top you can see wavelength decreases, frequency increases, as we know that they are inversely proportional, energy increases. So if the wavelength decreases, so definitely your frequency will be increases, because the number of cycles will be passing through that that vertical line more than if we decrease the wavelength. So here you can see that we here the size of the wavelength, like you can see here, the size of increases. So definitely if the size of wavelength is increases, so frequency will be decreases then. So here you can see that here we have more frequencies are passing through the vertical line. So definitely their wavelength is decreasing, but their energy is increasing, as they are inversely proportional. But here if you see the behavior, that that wavelength is increasing, so we can say their frequency will be decreasing. So here you can see that here we have, like, we have wavelength, as we know that we measure wavelength in meters and frequency in hertz. We know this, that and uh, mm, we measure uh, wavelength in meter, frequency in hertz, and energy in voltage or watts. So here you can see here that wavelength is 10 raised to power 3, 10 minus 2, 10 raised to power minus 5, and so on. Here you can see, if you see the frequency is increasing. So 10 is to power 4, 10 is to power 8, 10 is to power 12. So this is how they are inversely proportional. So if we increase the frequency, so the wavelength will be decreasing. So all the electromagnetic radiation move at the speed of light. Like we can see that this is 3 million micro milliseconds in a vacuum. So fill in the blank. If just I just want to know that you have grasped whatever we have studied. So microwave, gamma rays, and radio waves are all type of. So I think you know the answer of this blank. Light consists of oscillating dash and dash fields. I hope that you have answered. Light in a vacuum always move at roughly millisecond. We have just read this one. So want to show the answer here, that the answer here is electromagnetic radiation. So the answer of this is electromagnetic radiation. The answer of this light consisting of oscillating electric and magnetic fields. So this is the answer of these two blanks. So when we oscillating these two, so actually electromagnetic field is generated. Now light in a vacuum always moves at roughly, this is 300 million milliseconds. Now this is a assignment which you have to, this is actually a written assignment. You have to go through the links. I'll show that links as well on my resources slide on the next on the next slide. You can I have shown these links on my resources slide. You can go and find out more about this topic there, or you can Google all these terms. So this is written assignment, so you have to list all the waves with their frequencies and wavelength, and list two practical examples of each. So you will have to provide the practical example of each, that where each field is required. As you know that we have studied different kind of waves which comes under electromagnetic spectrum, like radio wave and microwave, and we have studied this. So you have to mention two example of each, that where we can use them. This will be more appropriate if you consider some communication examples, like we have in our computer field. We use different kind of these uh, uh, different kind of these spectrum or waves in different technologies. So this will be more appropriate if you mention the name of those technologies, that there where these waves are used, and what are the advantages of uh, each. What is the advantage of each? Now, these are the resources which I have used in making these slides. So you can visit each one of them and explore more about this topic. If you have any question, you can ask me through KCMS or WhatsApp. I'll be more than happy to answer your questions. So with that, we reach end of this lecture. So till next lecture, Allah Hafiz.